Good morning, Math219 and Econ365. Uh, this is the first lecture I'm recording, and I want to make these small for one reason. I seem to have trouble getting enough compression and uploading them on the network here if they're more than, say, 10 minutes. So it's a little crazy. It's going to be very short, just like one idea per lecture about. So it's probably all you can handle anyway, because I don't know how compelling they're going to be with just me writing notes. But that's all I intend to do for this. So give me feedback, and I'm going to continue to work and think of other ideas for things to do. But for now, I just want to write some notes, and we'll deal with it like that. Okay, so situation is, so let's write it. The whole point is for me to write this, and you can take notes too. So we have n rows, and m, say, greater than p, or greater than or equal to p calls of data. N rows and so many columns of data, and we want to pick one call as response and a set of p minus 1 other calls as predictors. What set would be the best? Would best explain the response? Okay, some notation. We'll write, say, SSE, and let's just write something like X, could be cute here. Let's just write X1, X2, X3 means SSE in the model with predictors X1, X2, X3. If we write SSE, say X6, this means SSE in an SLR model with predictor X6. So the X's, the subscripted X's, are vectors, right? They're columns from the data set. Okay, we're gonna have tons of videos. I can't go too long, so they'll be chopped up. All right, so with this notation, I could write a general, specify it generally. You just write SSE, and we could write a set notation in there or something, and it just means, so maybe we should do it since we're talking about it. So SE, and I could have a set in here, say XK, and this just means SSE with the set xk of predictors. Okay, so from here, we have something called extra extra sum of squares. And this is the idea of a marginal sum of squares. So, okay, so we know, so for example, so this is a marginal sum of squares. So a simple case would be, say, SSR x2 given x1, and this is defined to be SSE minus SSE. So the idea is that vertical line means what's the sum of squared regression when x2 is in the model, given x1 is already in the model. So when x2 is added to a model that already contains x1. So I want to express this as the difference of two SSEs, and it should be positive, probably, if it's going to make any sense. Model won't get worse if I add x2 to it, so it seems like you should get more explanation. It should be positive. So this should be, and we'll show it, should be x1 minus SSE x1, x2, because the x1, x2 is a better model, right? So that SSE is lower. So this will give me a positive number. I could also write it using SSRs. We could write SSR x2 given x1 is equal to SSR, the amount of explanation I get with, this is a little more intuitive maybe, x1, x2 minus SSR x1. Okay, can you prove these are the same? So, should be an easy proof. These are the same. Because SSTO is the same. SSTO is not a function of any predictors. So that SSTO equals SSE x1 plus SSR x1 by definition. But if I had a different model, it's still the same, so it's going to be SSE x1 x2 plus SSR x1 x2, and from there we can see that they're the same. I can now subtract, so subtract to show SSE x1 minus SSE x1 x2 must be equal to SSR x1 x2 minus SSR x1. And whether I write it one way or another, this will be called the extra sum of squares, or the marginal sum of squares of x2 given x1. Notice the order does matter here. It's not the same. So let's do, for practice, let's do, well, you can pause it, right? Let's do another one. So for practice, what if we wanted to do the other way around? So practice. Express SSR x1 given x2 as in terms of SSEs. I should at least get some clean paper, right? If I'm gonna do. Okay, so could you do this one? Yes, you could. So now this is saying how much explanation do I get when I add x1 to the model given x2 is already in the model. And this should certainly be, you could see it should be SSR, the amount of explanation when they're both in. So SSR x1, x2 minus SSR when I only have x2. So you could flip it the other way then and just say this is SSR x1 given x2 is equal to SSE x2. Well, x2 is always in the model, so it better be in the parentheses on the right-hand side. Minus SSE x1, x2. That'll be bigger, right? Okay, etc. We could do another one. So, for example, express, suppose I want SSR of x1, x5 given x2, x3, and x4 are in the model. Well, I bet you already have it. So let's do it with SSE. So SSE, the bigger one, okay, x2, x3, x4 are always in the model. So I'm going to write this SSE x2, x3, x4 minus, now I've added the other two, so now I have all of them. SSE x1, x2, x3, x4, x5. Oh, good Lord. I don't know if the video is getting too long. Okay, this is the idea of extra sum of squared. I'm going to stop this now and we'll make another one.